Hey everyone. My name is Brian Lawrence. I'm the CEO and founder of Silktech Biopharmaceuticals. Today I'll be going over some of the progress we've made in developing our SDP4 biologic candidate for treating dry eye disease. We think it really is an innovative approach, and I'm excited to give you some updates today. So we all know dry eye, it's a disorder of the tear film. We really look at it through the inflammatory cycle where you've got a debilitated tear film that's breaking up and doesn't cover the ocular surface. You get irritation, inflammation, and that cycle just goes around and around, causing the patients greater and greater symptoms. And we look at that as there's really two opportunities, I think, in developing better approaches in dry eye. One is stabilizing the tear film, but also simultaneously reducing the inflammation. Of course, that's more difficult to undertake than it sounds. And so we're taking that approach at Silktech, and specifically, we've designed SDP4 to operate through a dual mechanism of action. And one is physical in that it stabilizes the tear film acutely upon installation of the eye drop. And then over time, it acts as an anti-inflammatory, inhibiting the NF-kappa B pathway to reduce ongoing inflammation. SDP4 is unique in the fact that it's derived from the abundant silkworm cocoon, and we've optimized it to function in an ophthalmic formulation. What's really interesting about this protein is that it's highly water soluble, but it has a multi-year shelf life stability at room temperature. And so it's ideally suited for use in something like an ophthalmic product. Pharmacologically, we've done a lot of testing, and we have a good handle on how the mechanism of action is working and also on how our enhanced tear film stability is affecting the ocular surface. And we have a broad defensible patent portfolio that's worldwide and protects us through 2037. So there's a lot of runway on the innovation of this. So just to dive into the chemistry and what the molecule is, it's a chemically modified silk protein hydrolysate. And it's composed of repeating peptide sequences, shown on the right there, mostly glycine and alanine repeats. But it's readily absorbed by the cells, which is unique for a protein therapeutic, and it gets inside intracellularly, and that's where it's having its anti-inflammatory function. The protein itself is around 20,000 Daltons in size and ranges from 10 to 30,000 Daltons in distribution. And the eye drop formulation has its own real interesting characteristics. So it's all aqueous, it's a transparent formulation, preservative-free, it's in a single unit dose container, and it's shelf-stable at room temperature for over 2 years. And we've made it into a process that's economically stable to address the dry eye market. So as you see in that video running in the bottom, it's probably the best demonstration of how the SDP4 interacts with hydrophobic wax surfaces or dry eye type surfaces. And what you see is a saline droplet on the left and a saline droplet with the SDP4 added on the right. And you can see how through increased adherence profile of the SDP4 containing droplet and then this enhanced spreading and wetting function, we can spread out over surfaces pretty readily, consisting of both hydrophobic and hydrophilic components, such as the tear film environment. And what's also interesting is that it doesn't compromise vision quality because this is not a typical lubricant where you would enhance viscosity. So when you put this on, it's like adding the tear film itself. There's no blurring of your vision. Now, SDP4 works on the NF-kappa B pathway, and it's really important to understand how active this pathway is in dry eye. So it's working throughout the entire ocular surface, and once this pathway gets overexpressed, it can have a chance to really negatively impact the physiology of the ocular surface. And it's working within the meibomian gland and lacrimal gland. It's also working within the corneal and conjunctival epithelium and in goblet cells. So this one pathway is working on so many targets that we're trying to hit in dry eye. And once this inflammation gets going, as we all know, this produces pro-inflammatory mediators, and this drives the chronic inflammatory signaling, reducing stabilization of the tear film over time. Now, the NF-kappa B pathway, I have it simplified here on the left, but any number of inflammatory stimuluses can come through and activate this kinase chain that work its way down to the NF-kappa B complex. This complex then gets activated, moves into the nucleus, and acts as a transcription factor that starts making things like MMP9, various interleukins, and TNF-alpha, to name a few, that go on to keep driving dry eye inflammation. When we add STP4, what we're doing is we're actually inhibiting that kinase activity with the NF-kappa B complex, and as a result, we're stopping those pro-inflammatory mediators from being produced. On the right here, you can actually see our dose dependency curve for one of the bioassays we run on all the batches we produce of STP4. You can see that we have a 20-fold reduction in overall NF-kappa B stimulation. And this is a fairly potent response. So when you combine that with the tear film stabilizing effects and this anti-inflammatory effect, we think it makes a powerful combination. And this also works to suppress those inflammatory stimuluses coming down through the NF-kappa B pathway, along with us reducing these mediators that can promote this chronic inflammation within these patients. And so the whole process is designed to try to get the tear film back to homeostasis as it relates to inflammation. So I'm happy to announce we started a phase 2b clinical trial in April, and we actually had our last patient out earlier this week, and so we're expecting top-line results near the end of this year. And this study was a multi-center, randomized, placebo-controlled, double-masked clinical trial where we evaluated both the safety and efficacy of STP4 in dry eye patients. It was a dose-ranging study where we had 4 arms, a vehicle, a 0.1, 1, and 3% STP4 concentrations. And so I'm looking forward to report that out to you all here fairly soon. Thanks, everyone, for your time, and I hope everyone has a good time at this conference. Appreciate it.